Hi friends, I am Vivek. Today I would like to explain my project Car Black Box, sponsored by Emertxe. My batch members are DK Abhishek, Syed Abdul Kader. In this video, I will explain what is Car Black Box and the implementation of Car Black Box. What are the tools required for Car Black Box project? Firstly, what is Car Black Box? Car Black Box is a device capable of recording events associated with the car. A car black box is either physically installed in the car or downloaded as smartphone app. It links to the GPS device that measures the and records vehicle speed, location, distance traveled, and time of the day is in motion. This device is widely used in aeroplanes. Nowadays, these devices also used in cars, trucks, and other vehicles. These devices mostly useful in investigating car accident. After a car accident, it is very important to determine how accident was caused and what are the factors influenced that accident. It helps prove liability after an accident. A black box records the events associated with the car like vehicle speed, airbag deployment system, braking activity, vehicle tilt, fuel monitoring. And the requirements of our project are knowledge in embedded systems, MPLab XID. MPLab XID is a software program which is used to build microchip projects with the help of X8 compiler. And Pixim Lab, it is a platform where we can implement our project. The output will be shown in Pixim Lab at the end of the video. In Pixim Lab, we use PIC16F877A microcontroller, and the peripherals are CLCD, digital keypad, potentiometer, timer, double EEPROM, and real-time clock. Coming to what is embedded systems? Embedded system is a combination of hardware and software which is intended to do a specific task, whereas a general purpose system is used to perform large number of tasks. The real-time example of embedded systems is a washing machine, because a washing machine is intended to do specific task like washing. It consists of hardware and software. The real-time example of a general purpose system is a laptop. We don't use laptop for single task, so it is a general purpose system. The embedded systems are categorized into four types. They are standalone system, real-time system, networked system, mobile system. First, standalone system. Standalone system is a independent system can work by themselves. It is subcategorized into two types: slave system and independent system. Slave system is a non-intelligent embedded system. These systems cannot take action by their own. Example, semi-automatic washing machine. And the independent systems can take action by their own. Example, Tesla car or Google car. And real-time system. These systems are time-bound system which will take action on specified time. Failures in the systems are not acceptable. These are subdivided into hard real-time system, firm real-time system, and soft real-time system. Hard real-time systems are used in life-critical applications like hospitals. Firm real-time system is a embedded system. It is okay to miss few deadlines, but missing more than a few deadlines will lead to total failure of system. And soft real-time system is a system whose operation is degraded if results are not produced according to specified timing requirement. That means it is acceptable to have some tolerance in meeting deadline. And the third type of embedded system is networked system. Simply, the system which are connected to network are called networked embedded systems. Example, home security system. Fourth one, mobile system. The system which are mobile are called mobile system. Example robots, Tesla car. And this is the components of embedded system. As we see, it consists of hardware like microcontroller, memory, FGPA, and other peripherals connected to microcontroller, and also software. How to choose an embedded system? An embedded system can be chosen based on these aspects like low power consumption, cost efficiency, efficiency use of processing power, reliability, efficient use of memory. And what is microcontroller and microprocessor? Simply an integrated circuit which is capable of being programmed to perform specific tasks. It has some design restrictions such as memory size, I/O capability, and peripheral functions. A microcontroller can be chosen based on applications, performance, price, availability of tools, special capabilities. Some basic differences on microcontroller and microprocessor. Microcontroller means all components will be in single chip as shown in the figure. It is less flexible and less design complexity. As shown in figure, all components are assembled separately in microprocessor. It is more flexible compared to microcontroller and it has more design complexity. It is picture board. It is where we show our output at the end of the video. This is Pixim Lab architecture. 16F877A is a microcontroller and LED, buzzer, digital keypad, CLCD, ADC are input output devices. The basic peripheral of any microcontroller is LED. LED is a simplest device used in most of the embedded applications as feedback. It works just like diodes and works in forward bias mode. LED is used because of it consumes low energy and longer life, small size and faster switching make it usable in wide applications. As we shown on slide, it is a symbol of light emitting diode. It is syncing and sourcing circuit of LED with device. In picture news board, we use a current sourcing circuit and CLCD. CLCD is a type of liquid crystal display. CLCD stands for character liquid crystal display. In Pixim Lab, there are two types of displays: 16 cross 2 display and 16 cross 4 display. It displays the ASCII character and some special characters. 16 cross 2 means 16 characters and 2 lines. Similarly, 16 cross 4 means 16 characters and 4 lines. It has 16 interfacing lines and it works on two communication modes. One is 4-bit mode and another one is 8-bit mode. Tactile switch. A tactile switch allows electricity to flow in circuit by manually pressing the operating section. As shown in slide, pull down resistor circuit and pull up resistor circuit are used in PIC board. PIC board manufactured was based on pull up resistor circuit. This switch is used to select the mode of operation and to enter the temperature and to enter the time in our project. This switch will produce a bouncing effect when the switch is pressed. Tactile switches are mostly used because of its simplicity and low cost interface and comes in different shapes and sizes. Some of applications of tactile switches are HMI, mobile phones and computer mouse. Digital keypad. Digital keypad is a group of tactile switches are connected in row and column. This is used when more number of user inputs and are required and still want to save some controller input output. These keypads are most commonly used in calculators, digital lockers, etc. As shown on slide, it is the interfacing of digital keypad with port B of a Pygenius board. Coming to interrupt. Interrupt is a signal from the IO device indicating an event that needs an immediate attention. Then MPU acknowledges the request and attends to the request. After completion of interrupt, it goes back to processing where it got interrupted. Polling. It is a process where a computer or controlling device waits for an external device to check the state, often with low level hardware. The disadvantages of polling are loss of events may occur during polling, poor response, less power management. Interrupts are classified into several types. They are hardware and software. Again, hardware interrupts are classified into non-maskable and maskable interrupts. ISR. ISR stands for Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an attempt. That means software routine that call hardware in response to interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in ISR. It must be terminated with the instruction RETIE. When interrupt occurs, the microcontroller completes the instruction being executed, then it disables global interrupt enable, places the address from program counter on the stack, and return from interrupt. As shown on slide, the program sequentially executes. When the interrupt caught, the control goes to the interrupt, and after completion of interrupt, the control comes back to interrupted program and sequential executes from there. Timers. Timer is an important application of an embedded system, which is a default peripheral which maintains the timing of an operation with external clock. It has many applications such as measuring time and generating delays. A timer is also used as counter. It has the following specifications: resolution, tick, quantum, and scaling. Let me explain the specifications. Resolution. Resolution means a register width, whether it is 8-bit or 6-bit, 16-bit. A tick key is referred as change from one number to another number. It may be up count or down count. And quantum, which depends on system clock setting, is a measure of time which is responsible for tick. And scaling, it is a factor we add based on user requirement, whether it may be pre-scalar or post-scalar. Modes of timer are counter, PWM, that means pulse width modulation generator, or PP measurement. And potentiometer. Potentiometer serves as an analog input to the microcontroller. Potentiometer is a peripheral which can regulate speed in our project. Analog to digital component is a main component in potentiometer and it is used to convert signal from analog to digital. A to D converter module has 5 inputs for 28 pin devices and 8 for 40 or 44 pin devices. The conversion of an analog input signal results in a corresponding 10-bit digital number. The resolution is for 8-bit from 0 to 255. For 10-bit, it is 0 to 1023. And coming to I2C protocol. I2C protocol is a communication protocol. I2C stands for Inter-Integrated Circuit. It is a way of serial communication between different devices to exchange their data with each other. It is half duplex bidirectional two-wire bus system for transmitting and receiving data between multiple masters and multiple slaves. I2C is a synchronous protocol. It is also called as two-wire interface. These two wires are serial clock line and serial data line. Masters and slaves play important role in I2C communication. Master is the one which initiates a communication, generates a clock and terminates communication. Slave is the one which is handled by master and acts according to the master command. It can also be available that multiple masters can communicate with multiple slaves. As shown in slide, it is a signal transmission. It has two masters and four slaves. That means it is a multi-master and multi-slave I2C protocol. SCL means serial clock line and SDA means serial data line. Signal transmission steps. First, the master checks whether the bus is idle or not. If, if bus is idle, then it sends a unique address to the bus. Then the slave sends acknowledgement to the master, which has that unique address. Then master read data from slave, and once the data is received, the stop of communication will execute by master. Bus speeds. Buses are available in two types, bidirectional and unidirectional. Bidirectional means it can transmit and receive signal at a time. Bidirectional buses are available in standard mode, fast mode plus high speed mode. And the speed of standard mode is 100 kb per second, and the speed of fast mode is 400 kb per second, and the speed of fast mode plus is 1 MB per second, and the speed of high speed mode is 3.4 MB per second. Unidirectional bus. It is a bus. It can either only transmit or only receive data. It available in ultra fast mode. Ultra fast mode runs with the speed 5 MB per second. It uses push-pull drivers. EEPROM. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. It is a type of programmable read-only memory that can be erased and reprogrammed using an electrical charge. The size and component of storage depends upon the requirements of user. Modern controller has a built-in storage, that is EEPROM and data flash. There are three memory blocks in each of PIC16 F8 77A devices. The PIC devices have 8K words across 14 bits of flash program memory. These devices have 128 or 256 bytes of data with an addressing range from 00H to FFH. H means hexadecimal. The EEPROM data memory allows single byte read and write. The flash memory allows single word read and 4-word block writes. The final peripheral of our project is real-time clock. A real-time clock is an computer clock, usually in the form of integrated circuit that is built for keeping time. Naturally it counts hours, minutes, seconds, months, days, even years. RTCs can be found running in personal computers, embedded systems, servers, and are present in any electronic device that may require accurate timekeeping. The benefits of including RTCs are RTC ICs have proved to be more precise than other methods like programming the timer of a controller. It frees the main memory system from critical tasks. It has low power consumption and improved frequency stability. Let's get into the project demo. It will explain by our friend Abhishek.
Hi friends, my name is Abhishek. I will demonstrate the output of our project. This is PixSim Lab software where we can see the output of our project. First of all, we want to do some settings. It is defaultly shows Arduino board. Let me change to PicGenius board, where we implemented the project, and this settings load X file is there for load the code which was built with MPLAB XID software, and we want to select the microcontroller as a PIC16 F877A. Then we want to choose the clock frequency as a 20, and LCD will be 16 into 2. This is PicGenius board. This is our dashboard where we see the time, event, speed, and we used peripherals like tactile switches from RB0 to RB5, and LEDs and potentiometers, double EEPROM as a memory, and PIC microcontroller, and RTC real-time clock. The default screen is dashboard. It consisting of time, event, speed displayed in the CLCD. We want to record the events, like the default event is on, and we want to record events neutral gear, reverse gear, gear 1, gear 2, gear 3, gear 4, and collision by using the tactile switches from RB0 to RB2. By clicking RB0, the event will be recorded as collide. Again, by clicking RB1, it will change the event as a gear neutral. Then gear reverse, gear 1, gear 2, gear 3, gear 4. For reversing the gear, we use RB2, gear 3, gear 2, gear 1, like this. We are using these switches. Here RB3, RB4 switches used for up arrow or down arrow. By clicking any of these, we can it will ask the password. First, we the password will be 4 digits, and it contains 4 digits password. By using RB3 and RB4, after 3 attempts, it will block the user for a specific time. First, we will try wrong password. Here, wrong password will be shown, and attempts also shown. By clicking the right password, we will navigate to the menu. Our password is coded as RB4, RB3, RB4, RB3. This is our menu. Here we have view log, clear log, and change password. First, we want to go to in view log by using RB5. This shows the events which will recorded earlier. This is serial number and time, event, and speed. By clicking RB4, we will go to next event, event 1, event 2, and so on up to 8th event. For navigating by using RB3 as a up arrow, you can see all events. This is the output of our project. Here, second menu is clear log. We want to go to clear log inside by using RB5. The logs are cleared successfully message will be displayed. Then the logs recorded earlier will be cleared. Then we see the third menu, change password. For going inside, we use RB5. Enter new password. RB3, RB4, RB3, RB4. We want to enter the same password again. Password changed successfully. Like this, we can change the password and view the logs of records. This is about our project. This is our completion of our project. Thank you for giving this good internship from Emertxe. Uh, Specific thanks for Rajini madam, who was our trainer, helped a lot to do this project. Thank you for watching.
Stay tuned to Soundworks for more updates. We'll meet in the next video. Thank you.